Hello and Assalamu alaikum everyone. Today in this very short video of few minutes I will be talking on a very interesting topic, that is catalysis. Its use in chemical reactions and its mechanism of action. I will also be highlighting some important reactions of catalysis. Although the term catalysis is very old, given by Berzelius in 1836, but this field has never died and will never die. It is because the research in the field of catalytic science has brought new dimensions in all fields of science, in all branches of science, and has revolutionized the whole world, whether it is biomedical science, whether it is engineering science, whether it is synthetic organic chemistry, coordination chemistry, catalysis in biosensor bio marker detection, or energy applications, etc. So everywhere the catalyst is nowadays being used, and the people are working in this field to produce new innovative materials for different types of the reactions. So let us talk about the catalyst. What is catalyst? You know that in a chemical reaction always there is either bond breaking, rearrangement of the atoms, rebuilding of atoms, forming new molecules. If some material, some substance is there which can make this process easy and using less time, consuming less energy, that substance is known as catalyst. So we can say a catalyst is a substance or a material which alter the rate of the reaction, and the catalyst itself does not get chemically consumed, changed, or destroyed at the end of the reaction. Catalyst can be a positive catalyst which will enhance the rate of the reaction, or it can be a negative catalyst which will retard the rate of the reaction. There are some reactions in which catalyst of course reduces the rate of the reaction that we will discuss. Now let us give me a brief classification of catalyst. Catalysts can be classified on different parameters, like on the basis of the physical state. Catalyst can be a gas, liquid, or solid. On the basis of their mechanism of action, catalyst can be a homogeneous, heterogeneous. On the basis of nature of the catalyst, it can be an inorganic or organic material. And on the basis of activity of the catalyst, it can be a acid-base catalyst, enzymatic catalyst, that is biocatalyst, or photocatalyst or electrocatalyst. So let us first discuss the some important characteristics of a catalyst. How a catalyst should be, which conditions should a catalyst satisfy, then it will be a good catalyst. Here are some points that we will discuss. First of all, the first important point is the mass of the catalyst used in a reaction should be very small. It should be the mass used in a chemical reaction of a catalyst, it should be very small. Number two, the catalyst should regenerate at the end of the reaction and without its mass getting affected. Its mass should not get affected and it should regenerate at the end of the reaction. Another point is that a catalyst, although affects the rate of the reaction, but it should not affect the thermodynamics of the reaction, that is like enthalpy, free energy, or the equilibrium constant, because the catalyst enhances the rate of the reverse as well as backward reaction equally. So the catalyst equilibrium constant is not getting affected by the catalyst. Similarly, a catalyst should be a should be highly stable catalyst, because it should be resistant to some deactivation by some impurity and all that. And catalyst should have minimum particle size so that its effective surface is very high, which will provide good active sites for the reaction to occur on its surface. That is why people are making are uh, synthesizing different variety of the materials having different architectures which will provide effective surface area, like porous materials uh, or materials having some different architectures, I mean flower like cubes, etc. So these properties should be fulfilled by the catalyst. In addition, the catalyst should be also very selective, because there is reactant and catalyst like enzyme and substrate reaction is selective, like that. The catalyst and reactant should be also selective, and the reaction catalyst is also always specific. For example, some reactions, the same reaction can be carried out by different catalysts, but the product same reaction be carried out by different catalysts, and we can see the different products. For example, a reaction of carbon monoxide and hydrogen catalyzed by nickel gives methane. Same reaction catalyzed by uh, copper and zinc oxide, chromic oxide, it gives methanol. And when the same reaction is catalyzed by copper, it gives formaldehyde. So catalyst is also very specific. We also use sometimes the term autocatalyst. What is autocatalyst? Autocatalyst means when the product itself acts as a catalyst. For example, in the case of the oxidation of the oxalic acid by potassium permanganate, manganese sulfate is produced which acts as a catalyst. So product acts as a catalyst, it is called autocatalysis. Similarly, hydrolysis of the esters produces acetic acid, and sometimes this acetic acid acts as a catalyst. It is also called autocatalysis. Another term is used, induced catalysis. Induced catalyst means when sometimes reactant, one of the reactants itself acts as a catalyst, and effect is the rate of the reaction. For example, one reaction is there, the oxidation of uh, arsenic sulfate does not take place, but when air is passed through a mixture of arsenic sulfate and sodium sulfate, both of them undergo simultaneous oxidation. So the reaction is induced by sodium sulfate. It means that reactant induces uh, one of the reactant itself induces the reaction. It will be called as the induced catalyst. So these are some basic terms which we use for the catalysis. Now let us come to the general mechanism of. First we will see the mechanism of the catalyst. Now, how a catalyst basically works. A catalyst, uh, when we talk about the mechanism of the action of the catalyst basically enhances the rate of the reaction. But how it does? Basically, the catalyst decreases the activation energy of the reaction. And how it decreases the activation energy, that we will also discuss. First of all, what is activation energy? We know that when a reactant gets converted to the product, the reactant has to pass through an energy barrier. It has to cross an energy barrier, which we call as threshold energy. Okay, then only the reactant will get converted into the product. Okay, the energy of a molecule in the reactants in the ground state is less. It will not cross this energy barrier. That means we have to supply some external energy to make the ground state energy of the reactants equivalent to the threshold energy. Then only it will get converted to the products. This minimum energy which is required to make the ground state energy equal to threshold energy is known as activation energy. So activation energy is basically the difference between the threshold energy and the energy of the reactants in the ground state. So lesser is the activation energy, more fast is the reaction. Higher is the activation energy, reaction is slow. So it means a catalyst lowers the activation energy. Now how the catalyst lowers the activation energy? I will show here the mechanism. This catalyst basically alters the path of the reaction. Alters the path of the reaction. Here I can show you a diagram on the right side where you can see a man is carrying a cart and carrying some materials in it, and it has to climb. Maybe it is a type of mountain. For example, it has to climb a mountain, and he's alone carrying this cart by uh, to climb this mountain and reach from point A to point B. Okay, but when the man which is carrying a cart, another man is coming and he's pushing his cart by choosing a different path. By choosing a different path, this different path is of course having less distance. That means he will cross this distance from A to B in less time, as well as need less energy. So this different path is chosen by the catalyst. Okay, so you can say here the second man is a catalyst. Okay, and which is helping him to drag this cart from point A to point B. Same mechanism is followed by the catalyst. It chooses a different path having less activation energy and hence increases the rate of the reaction. You can see here, for example, a reaction which is not catalyzed by any catalyst. So reactants are getting converted into the products. You can see here the activation energy is very high. Okay, but when the reaction is carried out in presence of the catalyst, you can see here the EA activation energy is getting decreased without affecting its free energy change. So this is the mechanism how a catalyst works. Now, the theories behind the catalysis, there are two theories which explain the mechanism of a catalyst depending upon the type of the catalyst. For example, intermediate compound formation theory. This explains the mechanism of the homogeneous catalysis where the reactant and the catalyst are in the same phase. For example, reactant and the catalyst are both are in the for example in gaseous phase. So what happens basically in this mechanism? A reactant, one of the reactant reacts with the catalyst to form an intermediate. Then the intermediate reacts with another reactant to form the final product, and the catalyst is regenerated. For example, here reactant A and B react to form AB in presence of the catalyst C. Okay, it form intermediate AC. Okay, then this catalyst along with reactant that is intermediate AC reacts with another reactant B to form product AB and releasing the catalyst. For example, some of the reactions like this are uh, synthesis of SO3 from SO2 and O2. Here NO is the catalyst. NO first reacts with the O2 to form twice NO2 as the intermediate. Then this NO2 reacts with another reactant SO2 to form SO3, and NO is regenerated. Similarly, dehydration of the alcohols to form ethers is catalyzed by sulfuric acid. Again, the intermediate formation by reaction of the ethanol with sulfuric acid to form ethyl hydrogen sulfate is an intermediate. Then intermediate reacts with another molecule of the alcohol to form ether, and sulfuric acid is regenerated. Another theory of catalysis is known as adsorption theory. This theory explains the mechanism of action of heterogeneous catalysis where the reactant and the catalyst are in different phase. Generally, the catalyst is in solid phase. The catalyst provides a solid surface for the reactants. So, in this mechanism can be explained by four steps. That is number one, the initially there is adsorption of reactant on the surface of the catalyst. Okay, when the reactant is adsorbed on the surface of the catalyst, and these reactants react at the surface of the catalyst, means catalyst provides a surface for the reaction. Okay, they form an activated complex. Then this activated complex undergo decomposition. Okay, after undergoing decomposition, it leaves the reactants after getting converted into product, and the catalyst is relieved. For example, you can see here reactant A and B, this solid catalyst, where on the surface of which two reactants are adsorbed, and then they form an activated complex on the surface of the catalyst. Finally, the reactant get converted into product on the surface of the catalyst. After that, the reactants are relieved and the catalyst is separated, and we get the product C and D from A and B. This is the general mechanism for the adsorption theory of catalysts. Okay, the same thing can be explained here like this. For example, we have a catalyst providing some surface here. There are two reactants A and B, and these two reactants A and B are reacting at the surface of the catalyst by adsorption of the two reacting molecules. After that, they form an intermediate with the, you can see here, adsorbent, this solid catalyst, and the reactants, they form intermediate, that is called activated complex. Then this activated complex undergoes desorption, that means releasing the product, and the catalyst is also released. So this is the mechanism of the heterogeneous catalysis. Here are some of the examples of the heterogeneous catalysis. For example, you can see here very old reaction, Haber's process, where we manufacture ammonia from nitrogen and hydrogen, and they are finely divided iron, molybdenum, they are used as the catalyst. Similarly, in the Ostward's process for the manufacture of the nitric acid, okay, uh, the catalyst is platinum asbestos. Okay. Similarly, in the contact process for the manufacture of sulfuric acid, the platinum asbestos or vanadium pentoxide, solid vanadium pentoxide, that is used as a catalyst. These all are examples of the heterogeneous catalysis where the catalyst provides the surface for the reactants. Now, now, now coming to the different applications of the catalysis, the catalysis play a very important role. It not only catalyzes the reaction but also helps us in the reduction of a number of the harmful byproducts in the reaction, and to give new different products, and also reduce the cost of the reaction, and also uh, reduces the wastage in the reaction. For example, applications of catalysis in the environment, many important environmental issues they can be addressed. For example, we can have many uh, processes like decomposition of different pollutants using catalytic process, whether it is air pollutant, whether it is water pollutant, or soil remediation can be carried out with the help of the catalyst. Similarly, for the hydrogen production, carbon dioxide reduction, biomass volatilization, we can use a catalyst in these processes in the environment. In the green chemistry, catalyst plays very important role because we can have different types of the catalysts where we can carry out the reactions in which we have less toxic substance or nil toxic substances. That means products using the catalyst to carry out such reactions, like in case of pollution control, halogenation processes, uh, some reactions to avoid toxic chemicals. Similarly, fuel cells for the regeneration of the for the production of the hydrogen gas, we can use catalysts. So this is the application of the catalyst in the green chemistry. In catalytic converters, here basically these catalytic converters are used in the automobiles, where catalyst plays the role for the reduction of the harmful substances, reduction of the emission of harmful substances like carbon monoxide, nitrogen oxides, they can be their emission can be reduced using the catalyst in the catalytic converters. Similarly, in the ozone depletion, you know that ozone depletion takes place by the uh, uh, this free radicals which are generated from the chlorofluorocarbons using ultraviolet radiation, where these chlorine radicals they act as the catalyst. Similarly, in the chemical industry, like hydrogen industry, natural gas processing, petroleum refining, petrochemicals, fine chemicals, environmental catalysis, the catalysts can be used. Fine chemicals, number of fine chemicals they can be prepared using catalytic methods. Uh, Similarly, yes, very important. Some shape selective catalysis. You know that the reaction between the catalyst and the reactant, it depends largely on the structure, shape, size of the catalyst as well as the reactants. Okay, this is known as shape selective catalysis. For example, uh, in industry, zeolites as a catalyst, they are used in the petroleum industries for cracking the hydrocarbons. Okay, for example, very important zeolite, which is used as a catalyst to convert alcohols into gasoline directly. Okay, so this is called shape selective catalysis. We can have different varieties of the catalysts having different shapes, different structures, and accordingly they will be having different applications in different directions. Energy processing, catalysts also play a very important role in the energy processing, because we can have in petroleum refining. Okay, uh, catalyst plays a very important role, like in this catalytic cracking, to break the long chain hydrocarbons into this smaller chain, smaller pieces. Similarly, in the fuel cells, these catalysts play an important role for both anodic and cathodic reactions. We can have production of the energy in fuel cells. Similarly, very important role in the supercapacitors. Catalysts play very important role for the um, for their use in supercapacitors for the energy storage mechanism, where we can have the electrodes of different varieties utilizing different sizes, different types of materials to store energy. So this is the use of catalysis in supercapacitor, that is energy storage. Similarly, in food processing, they also play a very important role. For example, the hydrogenation of the uh, vegetable oils to produce margarine, that is the artificial, which we call as artificial butter. So in that case, the renin nickel, finely divided nickel, is used as a catalyst to uh, convert this vegetable oil into this margarine by using nickel as a catalyst. So these are the some important applications. So I hope in this video uh, you will learn many things. Though I have less time, but I covered many things in this short period of time, and I hope this will be very much useful to you. Thank you. Thank you very much for watching. Assalamu alaikum warahmatullah.